The age of iron, fire, and belts. Alrighty, folks, there was a time before the hum of electric motors, before a man could walk into a shop, flip a switch, and bring a whole building to life. There was a time when power had to be made, and you could hear it coming. Sometimes it sounded like a hiss. Sometimes it sounded like a deep metal choof, choof, choof. And sometimes it was just a little engine sitting in the corner going pop, pop, pop. Now, if you ever stood around a hit and miss engine, you know there's something almost hypnotic about it. They don't run like modern engines. They don't scream. They don't rev up and try to impress you. They just sit there and wait. The engine fires, the governor does its job, and then the engine takes a breath. Pop, silence. Pop, silence. And you get to wondering, how many things did that little engine run? Because those old engines were not built to be decorations. They were built to work. And work they did. A hit and miss engine might be found running a pump. It might power a sawmill. And in a machine shop, that engine could be connected to an entire system of overhead shafts and belts. Now, that's something a modern fellow has a hard time imagining. Yepers, today you plug in the machine, you push a button and it comes to life. But in the old machine shop, power was a physical thing. You could see it, you could follow it, because an engine turned a shaft. The shaft turned a pulley. The pulley moved a belt. That belt turned another shaft. And somewhere down the line, a lathe began to spin. The drill press began to turn. A saw began to cut. The power traveled through the building like a mechanical bloodstream. And the overhead belts, well, they were the power grid of their day. They were everywhere. Long belts hanging from the ceiling, pulleys spinning overhead, shafts turning, and the whole shop moving as one machine. Now, I have to tell you, there's something about that I like, because you could look at it and understand what was happening. Didn't need a computer screen. You didn't need a diagnostic scanner. You know, one of the things is we had to be careful, though. That's why you had to watch out for the clothing getting caught. That's why folks had to be careful what they were doing. Yeah, sure didn't have to figure out if the belt stopped, you knew. If the shaft started making a noise, you knew it needed oil. If the engine changed its rhythm, somebody in the shop looked up, and that's where steam enters the story, because steam power, hey, that's a whole different animal altogether. Steam began with something simple: water, fire, and pressure. But those three things put together in the right way changed the world. Yes, Robert Fulton was very influential in the steam engine. The water became steam. The steam pushed the piston moved, and that movement could be turned into power. Simple enough to explain. But the consequences, well, they were anything but simple. Steam engine powered factories, they moved locomotives, they ran pumps, they helped drain mines, they drove machinery. They helped turn a country that was largely agriculture into an industrial nation. And when you stand next to one of those old engines today, it's easy to forget that what you're actually looking at, because it looks like machinery. Iron, brass, steel, a few pipes, a flywheel, maybe a little bit of rust, but machine represents an entire change in human history. For most of human history, people worked with muscle, human muscle, animal muscle, and the wind and the water. Those were the great powers of the world. Then God gave man a way of figuring out how to make heat. And then he could turn it into motion. And suddenly, the old limits started to move. Now you heard steam engines built for all kinds of work. Companies like Case became famous for building machines that could do that hard work. The kind of work that didn't care if you were tired. The kind of work that didn't care if the weather was bad.
Fighting with this thing all day.
Oh yeah? You want to explain to me a little bit how it does its thing? How you fire it up?
What it's doing right now, it runs off of two different gas lines. You have a hot pipe in the front. This does not have any electric to it. So the hot pipe actually acts as a spark plug.
Okay.
So when the gas comes in and the wheels rotate when it's time to fire, it lets just enough gas to go through to the hot pipe. As soon as it hits the hot pipe, it explodes. When it explodes, it pushes the piston back, spins the wheels to get them rotating again. Once they slow down, then it triggers itself to allow more gas to come through, then the cycle just continues.
Now, back in when they first ran these engines, what did they run them off?
This one here, let me listen to something real quick here.
Yep.
See that one again. Back in the day, this one here was actually run off of steam.
Okay.
This was a steam operated one. This is what they would call a half-breed.
Okay.
That one over there was an actual hit and miss motor that was run off of natural gas that was coming out of the ground.
Right.
This one here, once they figured out when they could actually burn the natural gas, then it was converted to the natural gas. So this one here was actually originally a coal-fired steam operated motor. This one here, I believe, I'm not sure, but I think this one is a 1907. That one there's a 23.
1923.
1923, correct.
Do you know where they took them out of, and what they?
This one here stayed in Pennsylvania all its life.
Okay.
This one here, I'm not sure where this one came from.
Okay.
Now you can still find these up in the mountains today. They're still out there, but it's just that you can't get in to get them, and they're so heavy. Without a crane, you just can't pick them up to get them out.
Yeah.
Now, most of them that you do find, they're pretty well stripped down too. Because a lot of people scrap them.
Yeah. So I'm thinking, what, oil fields, mining?
Yeah, oil fields, mining, almost any type of industry.
Sawmills.
I was going to say sawmills. A lot of lumber companies used them. These was what actually operated the cranes to load their vehicles and everything.
Wow.
So, yeah, these were used for a lot.
Machine shops, because I can see it
Absolutely.
in the machine shop.
A lot of manufacturing companies used them for run their main belt in order to operate the rest of the warehouse.
Yep.
Yep.
And your name is?
Oh, it's Jim.
Jim. Nice to meet you, Jim.
Oh, yeah. Yeah, they're fun to play with. That's all I do. I just come here to play.
I know.
You make too much noise at home.
Yes, the work that just had to be done. And you know, I think that's something we forget about the people who use these machines. We look at the engine, but we don't always look at the man standing beside it. Some farmer, some machinist, or some mill worker. Yep, some fellow with grease on his hands and a pocket watch in his vest. He knew that machine. He knew every sound it made. He knew how it behaved when it was cold. He knew what it sounded like when it was working hard. He knew when something wasn't right. There were no parts departments 5 minutes away. There's no online tutorial. There was no fellow on the internet telling you exactly what bolts were in. Yep, you had a wrench, you had your experience, and you had an older fellow standing behind you saying, "Now, son, don't do that." And he was usually right. The old machine shops were places of noise, and I mean real noise, not the kind of noise you hear in a modern factory, with everything sealed up behind safety glass. You heard those belts. You heard those bearings. You heard the hammers. You heard the saws. You heard the steam, and every now and then you heard somebody yell over the whole thing, because apparently in those days, ear protection was just yelling louder. Now I can hear some old timer somewhere saying, "Son, we didn't have safety equipment." And no, you didn't. You had common sense. Well, sometimes you had common sense. And sometimes you had a story about the time common sense failed. But that machinery built things. It cut lumber, it shaped metal, it pumped water, it made work possible on a scale people had never seen before. And there's something humbling about that, because we live in a world surrounded by power. Electricity is nearly everywhere. Engines are nearly everywhere. Computers are nearly everywhere. But the men and women who worked around those early machines, they had to understand power in a very physical way. They built the fire and tended it. They saw the steam and had to get out of the way. They saw the pistons moving. They saw the wheel turning, and they understood. If you put too much pressure in the wrong place, something was going to give. And sometimes it gave with a sound you could hear 3 countings away. Now here's the thing about those hit and miss engines that I really enjoy. They have patience. That's probably the wrong word for an engine, but listen to me. It isn't frantic. It isn't trying to get somewhere. It fires and then it waits. Pop and waits. Pop and waits. Somewhere in that slow rhythm, you can almost hear the old world. A sawmill running before daylight. Machine shop opening its doors. A farmer trying to get one more job done before the rain. And a young boy standing beside his father, watching that engine work. And maybe that boy grew up and bought an engine of his own. Well, folks, that's how a lot of knowledge travels. Not through books, not through training seminars, but through watching, through listening. Through standing beside somebody who knew. And that, in a lot of ways, is what the steam era was really about. It was about knowledge becoming motion. Man figured something out. He built a machine. Another man saw it, improved it, built another one, and pretty soon the world was changing. That was the Industrial Revolution. Now you walk through the display of these old engines, you can find them sometimes out in the woods, up in the mountains. I think it's easy to look at them as antiques, but in their era, they were technology, the newest technology. But I don't think they're dead. Not really. Because when somebody fires one up, the past doesn't just sit there and look at you. It answers back. You hear the first pop, and suddenly the machine is alive again. The flywheel begins to turn, the belt begins to move, and just for a minute, you're not standing in the modern world. You're standing in a sawmill, or a machine shop, or some farmyard 100 years ago. The air smells like oil, the floor is covered in sawdust, the belts are turning overhead, and somebody is standing there watching the machine. Watching sure everything's working. That is part of the history I like. Not just the dates, not just the names, the sound of it, the smell of it, the feel of it, because history was lived by people who had dirt under their fingernails, people who worked 12 hours and then came home and fixed something else. People who looked at a broken machine didn't immediately say, well, I guess we need a new one. They said, hand me a wrench, and they went to work. Steam, hit and miss engines, case, the old belts, the shafts, the boards, all of it was part of a world built with iron, fire, and a whole lot of noise. Maybe that's why these machines still capture our attention. Because they remind us of something. The future didn't arrive all at once. It came one engine at a time, one shop at a time, one belt turning, one old feller showing a young fellow how to make it work. And standing here listening to one of these old engines today, you realize that machine isn't making noise. It's telling you a story about work, a story about invention, a story about a generation that didn't have much. But they knew how to build. If you listen close enough, you can still hear it. The old age of iron, fire, and steam, and somewhere in the dark, one little hit and miss engine is still going to go and be going pop, pop, pop. Folks wonder why I like old machinery.